Logarithm. What is logarithm? Why we use logarithm? What are the advantages of logarithm and who introduced for what purpose the logarithm? So these are some questions which we are going to explore and answer in this video. Keep watching this video. I will try to explore it in a very simpler way which you will understand easily. The term logarithm for the first time introduced in 1614 by John Napier for the purpose of simplifying calculation that were used by navigators, scientists, engineers, surveyors and others to perform high accuracy calculations. By using logarithm table, a lot of complicated problems and multiplication can be made easily by converting them to a simple additions. So logarithm is the second form or the inverse representation of exponential form. For example, if we have a number in exponential form, that is a power x is equal to y. So logarithm is the inverse representation of such type of exponential form of number. Like for example, how we can write it is log. This is the representation of log and this a is in the base. So writing it in a base form, just interchanging x and y. So here we can write y is equal to x. And how we say this format, that is log of y to the base a is equal to x. Log of y to the base a is equal to x. This one is the inverse representation of exponential form. Why we use logarithm? Logarithm. We use logarithm because in some cases if we have a problem that is a power x is equal to some number and we are asked to find the value of this variable. So we have no choice except logarithm. We will use logarithm to find this value of logarithm is the inverse of exponential form. If we have problem like this, that is 2 to the power 4 is equal to 16 and it is equal to 16. So another representation of this number and the inverse representation can be written as log of 16 to the base 2. This base is here also it is the base 2 and in this representation also it is in base equal to 4. It is the second representation of this format. And next, if the base is another number, the base may be different, but commonly we use base 10. That is equal to log of x to the base 10 is equal to y. And this is known as common logarithm. This base may be different number, but here commonly we use base 10. In 18th century, Leonard Euler introduced the another format of logarithm, connected this one to the exponential one and introduced e. That is, he used this e in the base form log of x to the base e is equal to y. In 18th century, this term was introduced and John Leonard says that this is natural logarithm and we denoted it by ln. Natural log of x is equal to y. Then we will not write base e, just it is natural logarithm. It means that logarithm naturally. X. Let's take another example, that is log of 1 to the base 10 equal to what? Let's find it by using the property of logarithm, that is it is the inverse form of exponential function. So writing 10 to the power x is equal to 1. Now what x should be, that is the left hand side equal to the right hand side. So x must be 0. That is why 10 raised to the power 0 is equal to 1. It means that the value of x is 0. What does it mean? That means that log of 1 is equal to 0. Now look at the behavior of log of 0. Log of 0 to the base 10 is equal to what? Let's find out. 10 raised to the power x is equal to 0. Now what should be the value of x that make the left hand side equal to the right hand side? In other words, what should we put here that it makes 0? Is there any number? No. We cannot find any number for x which we put here to that makes the left hand side equal to 0. That's why log of 0 is undefined. Log of 0 is undefined. Okay, now look at the negative numbers. Log of minus 2 to the base 10 is equal to x. Find out the log of this negative minus 2. Look at here. 10 raised to the power x is equal to minus 2. Can you find any number for x in real number that makes it minus 2? And as we know that exponential function cannot be negative. So negative numbers are not defined in logarithm in real numbers. In real number we cannot find the logarithm of negative number. It has a solution, but that is in complex number. So we will discuss that in another video. There are 4 basic arithmetics used in logarithm. That is number 1, product. Number 2, quotient. Number 3, power. Number 4, that is root. So how these arithmetics can be used in logarithm?